Hello there, and here is a video with a strange title which hopefully gets your attention and, trust me, will actually make some kind of sense. Sneak Thieves and Unicorns. And so, yes, Purple Monkey's playing the part of the sneak thief, and here he is arm wrestling a unicorn which has one real hand. Nothing creepy about that, but hey, AI does my artwork. That's the only part AI plays in this whole circus. So, without further ado, let's actually go into some examples because this is actually going to be about CRISPR Cas9. There aren't actually any unicorns involved. So, it's all about the probabilities. That's what I want to say. And so here is an example from a paper from a dear friend of mine, a friend and colleague who I still work with, obviously, because it's from this year. Point is, here you have your left-hand guide RNA, your right-hand guide RNA, and here, like, are the wobbles that I made earlier. And as luck would have it, this is pretty close to the ideal scenario. Not only are these guide RNAs really nice and close to each other, they're within, basically the tail ends are within 10 bases of each other. So that is your fantasy. Yes, we got unusually lucky with this pairing, and the mutation is contained within the guide RNA itself. So Garnelf spells Gary Elf, which always gave me a tickle. Point was, this is an ideal scenario because basically between the two guide RNAs, this is where the two nicks take place, and it results in an artificial recombination hotspot. That the closer the mutations are to this location, yeah, I know it seems counterintuitive, but yes, the mutation is so close it hurts. I mean, the only place it could be closer is literally there. But within the guide RNAs, even better, because one can scarcely exist without the other. But here is one of the phenomena I'm going to introduce you to, is that, yes, in a regular world, you would expect both of these guide RNA immunities to be conveyed. This is the obvious and normal thing, but it's not the only thing that can take place. What can take place are two other events. For example, as strange as it may seem, only this section could be included, and somehow, despite, the Cas9 nicking away and so forth, it's nicking, not cutting, is the point. That if this region of immunity is incorporated into the genome of your organism of choice, in this case it's a mouse, then it disables the Cas9 attack, and so therefore no more cutting, no more recombination. That shuts down, and whatever is set is set. And because it's taken the guide RNA immunity for at least one, I refer to it as a sneak thief because it's stolen the bit that it needs, but doesn't include the bit that you actually would like it to have. Yes, it's a remote chance in this case because, the other guy contains the mutation. So not the greatest example, but let me go forward, because conversely, it's a non-zero chance, however remote, that you could only get this section incorporated, including your precious mutation. And as a result, because it's a freak event, I would refer to it affectionately as a unicorn, which, yes, caused more than a few raised eyebrows in lab meetings. But hey, it made it much more memorable. People remembered Sneak Thieves and Unicorns rather than, rare probability events. But switching to another example, similarly, this one is also pretty desirable. This also is published, incidentally, same author, but I was also the middle author in there somewhere. Point was, different mutation, still mice, still the same gene, good old OGT, and yeah, here we have a C to Y mutation once again. So the possibility of a unicorn here or a sneak thief there does exist. It's a thing that takes place. And maybe these aren't the best examples, but I want to pick from published ones. So now for the best example, which also from the lab that I work in, here is the tail end of the OGT gene. And here marked are two naturally occurring restriction sites, which we use for screening of CRISPR. So we wanted to stick a triple HA tag onto the very, very end of OGT. And so what did we do? Because, the CRISPR guide RNAs, they have to occur in the coding region because you have to be able to wobble and therefore eliminate the guide RNA sites. So there was no way of being right at the end. In fact, right at the end was risky as well as unlikely because we didn't have any potential PAM sites which could then cause guide RNA sites. So what did we have to do? We had to go all the way here. And let me show you. Here's just the right-hand guide RNA. The left-hand guide RNA is there, but it's off the far end. Point is, this blue insertion here, it's not super crazy close to the location of the guide RNA. So this carried a real probability of the triple HA just being skipped. Not only because the triple HA is a bit of an intrusion, so that's also a factor that's going to harm your probability of insertion. But the point is, the guide RNA sites over here, you've got, I'm not going to count it, but the point is, with each successive, say, 10 nucleotides, your odds, are slowly creeping down. I mean, 50 is fine, 100 is survivable, and this is within the 100. Point was, we were still taking a little bit of a gamble, but because we had handy-dandy restriction screen and also a PCR-based screen that showed a size difference, we were able to screen out the guys that we wanted. But the point was, this serves as a great example of when you are running the risk of having a sneak thief ruin your day. In this scenario, hey, unicorns didn't even come into play because you have to eliminate one of the guide RNA sites, or Cas9 will keep on coming on in, and in the case of nickase, just nipping away. But yeah, one of the sites has to go. So I guess in a unicorn scenario, it'd be the right-hand guide RNA plus your triple HA. But we never saw that. Hey, it's all good. We still got our goal. We got our cell line. And as a result, we had an affinity tag to distinguish the modified OGT. Very, very handy. And then we could overexpress tagless OGT. Well, but hey, if you're curious, look up the paper. It's an absolute banger. But what are the takeaway messages from all this? And trust me, there's more than a few. So let's go through them. Here are the things to keep in mind. So yes, the further from the cut site, the lower the recombination rate. Sounds obvious, and it is, but it's something that you can't lose sight of. You have to keep it in mind when you're planning your strategy and when you're thinking of what's going on. And also, back to the sneak thieves. Sneak thieves are a risk with distant mutations, but they actually tell you something. Because, after all, when you're doing a new CRISPR project, you're concerned, did I successfully design the guide RNAs? Did I introduce them correctly? Did I provide the Cas9? Is my repair template doing its thing? And the sneak thieves are telling you the following. They're telling you, are your guide RNAs working? Yes. Is your repair template there? Yes. Is your Cas9 reporting for duty and chewing the furniture? Yes. The only missing yes is, did your mutation get recombined in? But, you're close. You're like 3 out of 4 yeses. So, as cold comfort as it is, sneak thieves are your friend in a strange, hapless sort of way. But also, unicorns are a bonus, but they are not essential. Usually. I say usually because there was one time which I can't name which gene it was or what mutation because it's unpublished so far, but we were trying to do a new mutation and the mutation was contained in one of the guide RNAs, so we were all feeling pretty confident about everything. However, when we saw both guide RNA changes and the mutation come in, then the cells would die weirdly fast, and we couldn't put our finger on it. It wasn't until, in amongst all of those, there was one unicorn that had only one guide RNA plus the mutation, and the other one had got skipped. The cells were fine, they were healthy, they were happy. As it turns out, in my wobbles, I'd inadvertently stumbled upon the super secret code that says, start splicing here instead of at the end of the exon. So I was accidentally, murdering these cells in an overly exaggerated and elaborate way, which caused me to have to actually redesign my repair template to intentionally create unicorns. I actually only wobbled one of the guide RNA sites, which you can get away with. This is a trick that you can add to your arsenal. I mean, I wouldn't encourage you to do it all the time because it doesn't help you, but it can get you out of a sticky wicket if you've accidentally made an error in a guide RNA repair template design. Okay, and finally, what if you're in uncharted territory and like in a brand new gene or a brand new mutation in a gene that maybe you haven't worked with before or that doesn't have a reputation of being easy to work with? What I call a fake wild type safety net is your friend. And what on earth does that mean? the answer is, let me illustrate with this previous example, which, yes, we actually had success and this was innocent, but for visual aid gesturing, I brought it up. So let's say you generate your repair template with your guide RNAs and also your change in place. But what if that change, even though it was, say, reported in a patient or wherever you dreamed up this mutation, what if it's actually fatal for the cells you're working on? Then you might only see, for example, a sneak thief of that. But, or, there's 101 other things that could happen. But a way to ensure that things don't get too weird is, as well as producing this repair template, produce one that still has the guide RNA immunity. However, this one, don't omit the mutation entirely. Let's not go that far, because not all mutations are so well situated. It could be way over here. In which case, make it a silent mutation. So still have it match the amino acid, but have it just with a little wobble, a little signature to say you were there. That way, if you, say, mix your fake wild type or do a separate wild type attempt, if you see successful incorporation of your fake wild type but not of your mutant, that, I hate to say it, is a big fat sign that your mutation is actually lethal. Or you can be cute and cocktail wild type and mutant repair templates in parallel, and then just roll the dice. And if the dice keeps on coming up wild type, oopsie doodle, don't try that method afterwards. But that's what I'm saying, is that keeping your mind on all the possibilities, as well as the possibilities of things that can go wrong in advance, will save you a lot of anguish and gnashing of teeth later down the line. And yeah, I hope at least some of this made some sense. And as ever, if you want to leave something in the comments, feedback, suggestions, requests, then feel free. And of course, if you find yourself enjoying my videos so very deeply and your wallet is just so heavy you want to buy me a coffee like Purple Monk, you may have had too much coffee, then feel free to follow this link to buy me a coffee and check out the links in my bio. And thanks for watching, and don't forget to like and subscribe.